Hi everyone, with this video we are going to go over the question 7 of this section B. Okay, so this question has maximum mark of the 14 points, and this question is based on the topic 5, the calculus section of your curriculum. So let's look at the question. So we have to consider the curve with the equation y equals x cubed minus x squared minus x plus 1. And question A, we need to find the first derivative of the function y and the second derivative of the function y. So in order to solve this question, we have to use the formula where f of x is equal to x to the power of 4 is happening when we differentiate this function, right? This is same as n times x to the power of n minus 1. You can also find this formula in the formula booklet, page 7, under section 5.3. Okay, so let's use this formula to solve this question. So question AI. So since we need to differentiate the function y, so we are finding the first derivative of function y is the same as 3 times x to the power of 3 minus 1 minus 2 times x to the power of 2 minus 1 minus, so this term here, right, has actually power, hidden power, right? So it's x to the power of 1. So using that information, we can also write it as 1 times x to the power of 1 minus 1. And for the 1, right, we know that we can just cancel it off. But before that, we also know that the logic behind this cancellation is same as you say there's a x to the power of 0 hidden with this number. And we know that x to the power of 0 is anyway equals to 1. So it doesn't really alter the equation, right? But we know that there is a 1 hidden, which is the x to the power of 0. And using that information, we know that when you differentiate this part, this is same as 0 times 1 times x to the power of 0 minus 1. So since we know this already, we can just cancel off constant. Then we have 3x squared minus 2x minus 1 as the first derivative of the function y. Then let's try the second derivative of the function y. So we are trying to identify the second derivative. So that means we have to use the first derivative. Okay, we are starting from the first derivative. So this is same as second derivative of y is same as 2 times 3 times x to the power of 2 minus 1 and minus 2 times this 1 hidden here. So let's not forget that 1, but we're still subtracting negative 1, right? And then we know that we have to cancel off that constant, right? So what we're going to do is we're just going to write our final answer as 6x minus 2. So we got our second derivative too. Then let's try the question B. So we know that the curve has a local maximum at point A, and we need to find the coordinates of the A using your answer to part AII to justify your answer. So question B, since we have a local maximum at point A, we can identify the x value of the local maximum point using the first derivative of the function y. So we have to set first derivative of the function y equals to 0 to find that x value of the local maximum point. So we're going to set dy over dx equals to 0. That means we have to set 3x squared minus 2x minus 1 equals 0. And to identify the x value, we're going to factor this, okay? So when you factor this, we get 3x plus 1 times x minus 1 equals 0. This means x value is equal to negative 1 over 3 or is equals to 1, right? Then let's check whether these points are both local maximum points or the just one is local maximum and the other one is local minimum. Okay, then in order to identify or justify whether this point is a x coordinates of the local maximum point or not, we have to use the second derivative. So this is where the second derivative has to be used. Okay, so we're going to substitute our x value into the equation of the second derivative, which is 6x minus 2. Okay, so when x value is equal to negative 1 over 3, we get 6 times negative 1 over 3 minus 2, which is same as negative 2 minus 2, which is same as negative 4. That means this value is less than 0. When the second derivative value is less than 0, we have local maximum. Then when x value is equal to 1, when you substitute this value into the equation, the second derivative equation, we get 6 times 1 minus 2, which is same as 6 minus 2 or 4, right? That means this value is greater than 0. So when x is equal to 1, we have a local minimum value. So that means this x equals 1 doesn't work. Only the x equals negative 1 over 3 give us the value that we want. Okay? Then using this information, we're going to identify the coordinates of the A, right? So we know that the x value of the local maximum point is negative 1 over 3. This is also the x value of point A. And also we know that our original equation is y equals x cubed minus x squared minus x plus 1. So we are going to substitute 1 over 3 into this equation in order to identify that y value. Okay, so when you substitute negative 1 over 3 into our equation, like this, we get y value equals to 32 over 27. Okay, so we can identify the coordinates of point A as negative 1 over 3, comma 32 over 27. Okay, then now let's try the question C and D. So the curve has a point of the inflection at point B, and we need to identify the x coordinate for point B. Okay, so that's question C. So in order to solve the question C, we need to know what this inflection point is, right? So the x value of inflection point can be calculated when you set the second derivative of the function y equals to 0. That means when you set 6x minus 2 equals 0, we can identify that x value, right? So the x value in this case is same as 2 over 6, which is 1 over 3. And this is the x value of the inflection point. And that means the x coordinates of point B is same as 1 over 3. Okay, then the line L is the normal to the curve at the point 0, 1, right? So using that information, we need to find the equation of the L. Okay, so L is the normal to the curve at point 0, 1, right? Okay, then in order to calculate this normal line equation, right, we first have to calculate the slope of this normal line, okay? And we also know that the slope of the normal line is the negative reciprocal of the slope of the tangent line, right? So that means we can use the formula ml times mt equals -1, okay? And means we can identify the slope of the tangent mt using the first derivative of the function y. Okay, then using the first derivative of the function y, which is dy over dx is same as 3 x squared minus 2x minus 1, right? So using this equation, okay, we are going to substitute that x value of the point, given point, into our the first derivative equation, okay? Then we can calculate the slope of the tangent as 3 times 0 square minus 2 times 0 minus 1, which is same as -1, right? Then using that information, we can say that the slope of the normal line is same as -1 over slope of the tangent line, which is -1 over -1, which is same as 1, right? So now we have a slope of the normal line. That means using the equation y minus y1 equals the slope of the normal line times x minus x1, okay? We are going to substitute 1 as our slope of the normal line, and we're going to substitute the point 0, 1 into this equation. So we're going to substitute 1 here, right? And the 0 here. Then we get y minus 1 equals to 1 times x minus 0. Okay, then we can say that equation of the L is same as y equals x plus 1. So we got our final answer.